Hello, everybody. I don't know where we signed off. So I'm not sure when you guys last saw me talking, but when you squared both sides of the equation, you got this expression here and this expression here. Then we added like terms, this like term with that like term, this like term with that like term, and we grouped them. So we got x squared plus 3x plus 2 is equal to 0. Then we factored to get x plus 2 quantity times x plus 1 quantity is equal to 0. Then we solve for x in both of those cases. Now let's talk about absolute value equations. So for instance, what is the absolute value of 6x minus 2 is equal to 3? What is x? The way you do this problem, you set it up in the positive case and in the negative case, okay? The positive case means 6x minus 2 is equal to positive 3. And then the negative case is that 6x minus 2 is equal to negative 3, okay? And you solve for x in both of those cases. So in this case, I get 6x, I add a 2, I get 5, so I get x is equal to 5 over 6. In this case, I add a 2, I get 6 is equal to negative 1. I divide by 6, and I get x is equal to negative 1 over 6. Okay? And the thing about absolute value equations is you need to check whether these values work when you plug it back in. So look, when I plug in my 5 over 6, I get absolute value of 6 times 5 over 6 minus 2. This should equal a 3. Let's see. The 6's cancel, and I get 5 minus 2. Absolute value of 3 is 3. It equals 3. It works perfect. The other one is 6 times my negative 1 over 6 minus a 2. Okay, so 6 is canceled. So I get absolute value of negative 3, which is 3, and that works. That satisfies this equation. Both the positive and the negative case satisfy this equation. So let's do another example, and then I have to move on to 2.7. What about absolute value of 4x minus 5 is equal to 1? To solve these, you set up a positive case and a negative case. You say 4x minus 5, positive case is equal to positive 1. 4x minus 5, negative case is equal to negative 1, and you solve for x. So I get 4x is equal to positive 6. That implies x is equal to 6 over 4, which is the same thing as 3 over 2. Here's one of them. Over here, I get 4x is equal to a 4 when I add positive 5 to negative 1. And then I divide both sides by 4, so I get x is equal to 1. And then you can plug it back in and you'll see that it satisfies the absolute value equation. So the absolute value ones are pretty straightforward. You may experience problems that have absolute value inequalities. So like absolute value of 3x minus 1. When is this less than or equal to 1? This requires something called the fundamental theorem of absolute values, the FTA. The fundamental theorem of absolute value says that you can decompose any absolute value inequality like so. Okay? So then you can solve for x by adding a 1 to both sides. And then divide both sides by 3. So you get, this is the range of x that works for the inputs. Now I got to move on to 2.7. So let's talk about solving inequalities. Let's say I have 2x minus 1. When is this greater than 3x plus 5? Again, an inequality has almost the same rules as equality, and we'll discuss that. So what I want to do is I want to solve for x. So I can subtract the 2x from both sides, and I get this. And then I can subtract the 5 from both sides, and I get this. So I get x is less than negative 6. So when it's less than, we put parentheses. So it's all these values here to the left of negative 6. That's the values of x that would satisfy that inequality. Okay. One of the differences between equations and inequations, equality and inequality, is a very cool thing. Who here knows what happens to an inequality when you divide or multiply by a negative number? You don't have to raise your hands. Tell me what happens to the sign. What happens to the inequality sign whenever you divide or multiply by a negative number? It flips. But have they told you why? Has anyone proven it to you why that's true? They just told you to accept it without questioning, right? Did any one of you all actually say, no, I'm not going to accept it. I need verification from your teachers? Did anybody do that and get in trouble? Or better yet, did anybody not do that because they knew they would get in trouble and they feared the consequences? Boom. We'll be seeing a lot of yeses. I know I'd get in trouble, and you want to stay out of trouble. That's rule number 1 of survival. Stay out of trouble. Yeah, you need to get in trouble. Yeah, everybody's like, I don't want to get in trouble. Getting in trouble is bad. If I get in trouble at school, my mama might spank me or this and that, right? That is very bad because you become indoctrinated to become a person that doesn't question. So you tell the questions that you have in your heart to go away, that I should not question because I will get in trouble for questioning. And that is the biggest piece of steaming manure I've ever seen or heard in anything, anywhere. So I'm going to prove to you why multiplying and dividing by a negative number flips the inequality sign. Okay? Let's start with the real line. Here's 0. Here's some arbitrary number A, and here's some arbitrary number B, where clearly A is less than B, okay? So in turn, this would be our negative A over here, and this would be our negative B over here. So over here, take a look. Negative A, negative B is less than negative A. Would you guys agree? Here's 2 equations right here, based off of just 2 points on the real line. Who here agrees that this equation and that equation is true? Well, they're not equations, they're inequalities. So A is less than B, clearly. Agree, good. And negative A is actually greater than negative B, right? So, very good. Notice what happens when I put these guys in very close proximity. I just brought this equation and put it down right there. Notice that if I were to flip them, negative A is greater than negative B. So I will put that right here. Now look at these 2 equations right here. A is here, A is here, B is here, B is here. The only difference is these have negatives and the sign is flipped, right? So notice that multiplying both sides of this inequality by a -1 resulted in the flipping of the sign. Do you see that? If I multiply both sides here, so A is less than B, multiply both sides by -1. Notice how I get negative A is question mark negative B. We don't know what the inequality is, but when we inspect it over here, because when we had A and B over here, when we multiply by -1, whoosh, they come over here. And then we notice the inequality is that actually negative A is greater than negative B. So we flip the sign. The sign went this way, it was eating the B, and now it's eating the negative A. That's precisely why whenever you multiply or divide by a negative number, that you flip the sign. It's a consequence of this phenomenon right here. That if A is less than B, then the negative of A would be greater than the negative of B. What do you guys think? That's cool. Yes, it's very cool. So what about absolute value of x minus 1 is less than or equal to 5? Okay, using the fundamental theorem of absolute values, we get this expression. Okay, then I solve for x. I add 1 to this, this, and this. There's 3 components. Adding 1 to here, I get a 3x. Adding 1 to here, I get a -4. Adding 1 to here, I get a +6. Then I divide by 3 to solve for x. Over here, I get a -4/3. Over here, I get a 2. So x ranges between -4/3 and 2. Pictorially, this is what this looks like. Here's my -4/3. Here's my 2. And since it's less than or equal to, we utilize brackets. Okay? So the interval solution, the solution interval for where, because x lives right here. X lives in here, okay? The solution interval for this inequality in interval notation would be bracket -4/3 all the way to 2, close bracket. That's neat. Yes, it is neat, Jay and Carrie. That's why when you multiply or divide by a negative number, the inequality value will flip. That's because everything to the right is greater than everything to the left. And multiplying by a negative swaps which one was greater. Here, B was bigger, but whenever you multiply a negative, B ends up being smaller than A. Pretty neato Dorito. That's funny, Joshua. Okay. Let's do and that's it, guys. Seems like that's it. We've covered all the material. I'm scouring here to see if there's anything else we got to do. I don't see anything. Yes, you're prepared to take exam number 1. As you can see on your calendar, exam number 1, well, you're not prepared to take the exam, but you have all the tools necessary to practice for the exam. We have covered the material. It does not imply that you have mastered the material. Don't let me lull you into complacency like that. Okay. Still have to work really hard, but let's view this calendar when the exam is. Exam number 1 is due. It's an online exam. It's due on the 20th of this month. That means it's not this Sunday, but next Sunday. Do you have a study guide for us? No, I do not. But what I do have is a YouTube channel filled with a myriad of videos that have to do with the subject material of this course. So I actually have complete the square stuff on there, quadratic equation stuff on there, linear equations on there, how to factor quadratics on there, how to use a quadratic equation on there. And don't forget, you guys have your bonus problem to derive the quadratic formula that you were forced to just know how to do and use, just to plug and chug. But I want you to derive the formula so you see where it comes from for your bonus. We can retake our homework questions even after we complete it, just to practice as well. That's correct, Carrie. You have so much practice problems. And the cool thing about the online stuff is, don't you like the instant feedback? It gives you instant feedback on the problems, right? Yes, yeah, that's the cool thing about the online learning is you don't have to sit there and wonder, am I doing it right? Is this answer correct? No, it shows you how to do it, and if you don't know how to do it, and then it gives you another problem of similar nature. So that's what's really cool about the online platform. My YouTube channel will give you more than enough, because actually absolute value inequalities are also on there. So if you want more practice on absolute value inequalities, you can get that as well. Is there any more types of problems you guys want to review? Because now we're technically in review session, even though we have like 2 minutes remaining in official class. I'm willing to answer a question or two. If you have it. If you don't, then I'll see you guys later. I got to do my 3-hour lift anyways. I don't have any questions, boss. Bye, guys. See you, Jay. Is it chest day? Oh, good question. So when I work out for 3 hours, I have the luxury to hit every muscle. So yes, it's chest day, it's back day, it's bi day, it's tri day, it's delt day, it's leg day, it's ab day, everything day. It's a total body isolation day. It was back day for me, best day. Oh, you just hit back alone? I could never just only do back, and I can never just only do chest. If I do chest, I have to hit back. If I hit back, I have to hit chest. It's just about being like symmetrical. It's my preference. I feel better if I hit chest and then I go immediately hit back. I feel like my body is more postured, and furthermore, my body has more symmetrical strength, and also my chest gets to rest while my back is going crazy. My back gets to rest while my chest is going crazy. Yes, and shoulders. You got to hit shoulders. You got to hit back. You got to hit bicep. You got to hit everything. What gym are you going to? I have a gym that's really near where I live. It's 24 hours a day, 7 days a week. I like to mix it up. I'm doing legs tomorrow, then I'll hit shoulders. Gold gym is where it's at. I'm trying to get into gold. Yeah, I used to go there. So guys, any math questions? If not, I'm about to dip. Have a good night. You have a good night too. Without further ado, I'll see you guys later.